This is 2012 question number 44. Before we move on, you should have gone through the video about the section B probability. In this question, there are 6 balls with different numbers, and then you can repeatedly draw one ball from the bag without replacement until you get a 9. So you're asked to find the probability of having exactly 3 draws. As in the learning video, we try to use a tree diagram to help you to understand better. So the first draw can be a line or not a line. Since we need to have exactly 3 draws, the first one can't be a line. Therefore, the first one is not a line, and then we continue with the second draw, which can be a line or not a line. So once again, we need to have another draw, so the second draw cannot be a line as well. So for the third draw, we finally get a 9, and then this tree diagram shows you how we can get the final outcome. For the calculation, you need to first find out the probability of the first ball not a line, and then you also find out the probability for the second ball not a line, and finally the probability of getting a line for the third draw. And then we need to use multiplication. For the tree diagram, as long as it follows the path as shown by the red line, we will multiply all the probabilities. For finding the probabilities, you need to count carefully. For the first draw not being a 9, there are 3 numbers out of 6. Therefore, the probability is 3/6. But be careful, because you have taken out one of them and then it is done without replacement. Therefore, we now only have 2 balls not being 9, and the total number of balls becomes 5 instead of 6. Therefore, the probability of getting not a 9 for the second draw is 2/5. Finally, for the third draw getting a 9, you need to know that the total number of balls is now 4, and then we have 3 of them being 9. Therefore, the probability is 3/4. Finally, we multiply all these probabilities, which is 3/6 times 2/5 times 3/4, and you will get the final answer. That's it. Hope you like this video.